I'm going to talk about how to get more of your application behavior under unit test coverage. In this diagram, I refer to them as logic tests because I want to avoid the association of the term unit with compilation unit. I don't think the word unit in unit test was referring to a compilation unit, so when I say unit test, I'm referring to testing the behavior of your application that is under complete control of the rules of the programming language. A very common mistake when it comes to application maintainability is to put behavior in a place that is harder to test than necessary. Some common examples are putting behavior in your main entry point, behavior in a configuration file instead of a programming language, relying too heavily on a container to control behavior when the container should only be controlling resources it is responsible for, or surrendering control of your application to a framework that has an additional setup cost to test. For example, one of the most difficult situations to test that I have ever come across was conditional logic in shell scripts launched by a Jenkins automation server. Test driving the design of your code with unit tests is a great way to ensure you put your application behavior in places that favor maintainable code. I find easy to test and easy to maintain are so closely related that I sometimes use the terms interchangeably. You should strive to have the vast majority of your code under unit test coverage, only resorting to the more heavyweight types of tests when there is a potential for something to break and there is no other way to test it. To illustrate how to favor unit tests over more heavyweight types of testing, I've created a sample Java Web Archive project. If you're new to the craft of software engineering, a Java Web Archive is a good thing to know how to create. Java is a very popular programming language, and web applications are a very common need. Before I dig into the structure, let's make sure we can run the application. I have not chosen a Java Web Archive because I think it's the best way to write web applications. I personally prefer to end up with a containerless executable jar file using something like an embedded Jetty server to handle the web server capabilities. However, Java Web Archives are very common, so chances are you will have to deal with them eventually. Before digging into the implementation details, let's make sure we can run locally. So first of all, let's clone the project from Git. Okay, we're cloning hello web. I go ahead and change that directory. And let's do a Maven package. Okay, so since I don't like having to remember how to run something, I usually put a run shell script in here. For now, I'll just output it to the console so you can see what it looks like. So you see here, I'm just running the Java jar, and I'm running this using this Jetty runner and the web archive. So let's go ahead and run it. And I've provided a couple of examples to test it out with, so let's check these out and see what it does. So here we see we have the hello command with a target of world, and it just emits hello world to the output. If I change the target to Sean, again it says hello Sean. Okay, let's see what else we can do. The second command I've implemented just is a different command name, which is length, and target of world gets length of 5. Also, if I do Sean, gets length of 4. So pretty contrived and simple application just to illustrate the concepts. So what is common with this type of application is someone will write an integration test that spins up the web server to test the first command, the hello command, and a separate test also depending on the web server to test the length command. So I'm going to show a way to not do that and instead test the entire thing with only unit tests. So let's dig into the implementation details. Since it's a web archive, we start with the web XML. And we see here that I have an entry point, entry point servlet, and I have mapped every single URL pattern to that entry point. So a common problem with multiple entry points is when you have multiple entry points, what you've really done is you've placed the behavior of which entry point is chosen into a place where it's hard to test. So here, by mapping every single request to the same entry point, I've now moved behavior out of the web XML and into a place where I can test it. Now all the behavior is an entry point servlet. So by not having more than one of these, you've actually moved the behavior of dispatch into a place that's easier to unit test. Now let's take a look at the entry point servlet itself. This is acting as a bridge from the web container to the source code you control. So since this is a boundary, I actually don't want to put any logic here either, because the boundaries tend to be harder to test. Pushing the logic further down into the application allows me to ensure this class never has a reason to change. We need to test everything that can possibly break, so by making sure this code never needs to change, we have eliminated one file from the need to worry about it. I want to clarify here that tests are not a substitute for actually checking for yourself that the code works at least once. As you're developing, you will want to actually be running the application to see if it works. What tests do is reduce the maintenance burden once you have gotten something working, so when a potentially breaking change is introduced in the future, you can be confident that a test will verify it. So going over this entry point servlet, you see here I have delegated dependency injection to a private static class. Right here, as the servlet is initialized, I forward along the servlet config to the dependency injection class in case it needs it. Then finally, I have the service class, which goes and finds the top-level servlet request handler from the dependency injection class and handles it. So as you can see, I'm just pushing the code away from the servlet and towards an area that's a lot easier to test. Next, let's look at the dependency injection class. First off, I've pulled in the servlet config. Normally I would not pull this in until I actually needed it, but in this case I want to make sure the entry point servlet never has a reason to change, so I'm taking care of it now. Finally, we create all the classes we need and constructor inject their dependencies. I like constructor injection over setter injection because it makes it very hard for me to forget something without the compiler letting me know. At this point you might be tempted to use a dependency injection framework to handle this, but there are some disadvantages to frameworks you should be aware of. I refer to library as something your code invokes, while a framework is something that invokes your code, much like the WebXML is specifying which servlet will be invoked. By surrendering control of your application behavior to a framework, we are back in the same situation we started with regarding WebXML. Now you can't test your code without dealing with something you don't control. Keep in mind, Java is a compiled, statically typed language. Some dependency injection frameworks take away your type safety because they use a configuration file instead of code, so many problems that were discoverable at compile time are now waiting to surprise you at runtime. They can also instrument your classes with proxies, making your stack traces harder to comprehend. If your framework relies on annotations, it may also have to do a component scan across all of your code at runtime. Compare that to how simple, statically typed, and easy to understand constructor injection is. Even if you needed lazy instantiation, you can implement this in just as many lines as you could have in an XML configuration file. So think about why you are moving behavior from a programming language to a configuration file, and if that really makes sense. Now that we've pushed all the logic into places that are easy to test, let's have a look at how we actually test the web dispatch logic. As you can see with the hello test, I'm using a utility function to construct the request, making this test simple and its intent clear. Notice that the web dispatch is actually under unit test coverage. I did not have to spin up a web server to ensure that the web requests are dispatched properly. By moving our logic away from the web XML, away from the servlet, and towards the unit testable area of our code, in this case value objects, we've made our code really easy to test. As you can see here, the tests are only concerned with the dispatch behavior and corresponding logic for each command. The tests are also very flexible. When I noticed the browser was sending me a request for the favorite icon, I was able to get that under test coverage as well by creating a value object directly rather than relying on my utility method. Looking at the dispatcher, all the code here was test-driven. The dispatcher does not know about the servlet request response interfaces. Instead, it only knows about these value objects that are easy to construct. The dispatcher could have been made aware of the interfaces. There's nothing wrong with that. It's just in this case I found dealing with value objects preferable to dealing with fake stubs and mocks. I prefer the term test-driven design to describe this style of testing. This emphasizes how unit tests make the design of your code better. Correctness is an important concern, but not as important as having maintainable design. If you don't have correctness but have a good design, problems are easy to fix once they are discovered. If you have correctness without good design, it's going to become increasingly more difficult over time to maintain correctness. Tests that are hard to write are less likely to be written at all, so eventually you will end up sacrificing correctness anyways. So what you should take away from this is that anytime you see conditional logic without a unit test, what you should be trying to do is moving that logic away from your container, away from frameworks, away from your entry points, and towards code you control where it is easy to unit test.